In a previous video, I've shown this graphic talking about how I'm working on my 286 system. That's my hardware that I've put together. And on that hardware, I have BIOS. In that BIOS, I've written in x86 assembly. And I implement things like interrupts for video services, as an example, or disk services, whatever it might be. And at this point, for an operating system, I've been able to get FreeDOS loaded and running on my system off of a CF card. And then for an application or applications that I've been building, I'm working in C++. So the idea is I can go in, I can build a C++ application, I can load it onto the CF card, I can boot FreeDOS, and I can run that application. And that application may call operating system interrupts like interrupt 21. It may call BIOS interrupts directly like interrupt 10, or it may call the operating system, which then calls the BIOS interrupts to get to my hardware. Or from C++, I could even go directly to the hardware. For example, writing to the video memory or the register to configure the video card settings. I can write and read that register directly. I can write and read the video memory directly from C++. And recently I've been working on some graphic routines, and I've done a lot of those graphic routines in assembly for my BIOS, which I've been accessing through interrupts up to this point. But more recently, I've been in C++ in this application up here and trying to manipulate the video memory directly and trying to do things with primitives like drawing a rectangle or a circle or some other shape. And that all seems to be working well. I'm directly accessing that video card memory, creating the shape in the video memory without having to go through the BIOS and the BIOS interrupts to do that. Well, on a recent post, one of the YouTube users, Shriva, if I'm pronouncing that correctly, my apologies if that's not right, but he had asked a question, wouldn't you want to put the primitives for the graphics in assembly and not in C++? And I think in theory, the performance would be better if I was to do that in assembly, assuming that my assembly skills are good enough to write better assembly than what I could do in C++. But then the question is, how do I, from C++, access something that I've assembled in assembly? And I thought, well, let's go look at it. What's it going to take to get into this and actually make that happen? So my goal is to get to assembly functionality without making an interrupt service call to the BIOS assembly. Instead, I want to actually have assembly, like a library that I can write and then use from multiple C++ applications, or build it into my C++ applications using a common library that I've written. And that means that this is on the CF card in my system running on top of FreeDOS. So I decided to go ahead and get a new project started in Visual Studio. And I'm just using Visual Studio as a fancy text editor is all. I'm not assembling, I'm not compiling, I'm not linking with anything from Visual Studio. It's just a text editor. But my goal is now to get from C++ to assembly within my application that runs on FreeDOS. And so here's an example of what I've started just as a simple test. So it's a simple procedure that adds two numbers. And so it's going to take in two parameters, a num1 and num2, and it's going to return the result of those two numbers added together. I might not have this entirely right, but this is what I have at this point, and let me maybe just point out a few things. So first of all, I have the procedure add two nums, and I have to put a prefix of an underscore on it based on the calling convention that I'm using, which is the C-style calling convention. If I was to use, for example, a different calling convention, that's how my C++ is actually going to get into and make a call into this procedure. One of the other options I could use is the Watcom calling convention. And for that, I then, instead of an underscore up front, I have to put an underscore at the end as a suffix. But I'm going to use the C-style convention. And I've created a procedure. I've said make it global, expose it outside of this whatever assembled file I'm going to create. And then I come in here and I say, treat my arguments. I'm going to have a word on the stack. I'm going to call num1. I'm going to have another word. I'm going to call num2. And I have some comments up here that just show that num1 should be BP plus 4, num2 should be BP plus 6. So that's my base pointer plus 4 for an offset or 6. And when I get out of this, whatever's in AX is going to be treated as the return of the function call when I'm in C++. So this %arg just gives me a friendly name to work with these things. Instead of saying BP plus 4, BP plus 6, down here in my code, I can say num1, num2. So that's kind of handy. I do have some questions and some testing to do. This push for this context, this is a NASM feature. That might be doing the same thing as what I'm doing down here. So I need to double check that, or if someone here knows as you're watching this, if I should be using both of these, or if I can scrap the push and also the %pop down here at the bottom. That might be the case. But essentially I get in here, I move num1 into AX, I then add num2 to it. And then when I leave this, that is in AX, that will show up as my return value. I do have the stack size in here, and I'm specifying large. And if I come over and I look at the documentation in NASM, it just basically says that if I do a stack size large, then it's going to assume that a far call was made to get into this. And maybe that will always be true, not always be true, but basically I just want to make sure that when I'm in my executable and I'm going to access this assembly that's going to get linked in and compiled with it, that's going to work correctly. And I do know this works for my test scenario, which I'll show you in a minute. I did have to have this set to large when I was doing testing from my previous BIOS code. That was the first time I had used some of this push, stack size, and %arg. So large has been working, and I think that's what I need to be using, but I'll learn more as I move forward on that. And then I ultimately have to take this code and build it. Now, normally when I've been doing my BIOS, I'm building it into a binary file, and I burn that onto my flash memory chips. Now in this case, I'm going to instead create just a file, an OBJ file, an object file. So here I'm going to use NASM. I'm going to pass it in a file name, whichever file name I'm working on here. For example, if this was graphics.asm, I'm going to pass it graphics.asm when I call this build ASM batch file that I wrote. And it's going to create a graphics.obj file. Then I can get over to my C++. And here's an example of just something to test. Can I do that, add to nums successfully? And you'll notice that I have this extern C. So I'm referencing something external to the C++ code, and I'm going to use this C style calling convention. And to make that work, I have to put in this __ cdecl. And that's going to use this convention here of C. Now the default would be Watcom. And with Watcom, you'll see here that it passes the parameters in the registers, so A, B, C, D. And I don't want to use that. I want to use the stack so I can have as many parameters as I want instead of running out of registers. So in this case, I'm telling it that I want to use the C calling convention. I'm going to have a procedure called add to nums. It's going to take an unsigned int, or basically a word for num1, one for num2, and it's going to return an unsigned int word. And then in the main code, you can see pretty basic stuff here. I just say, let's add two numbers, enter the first number, and then I read in that number. I ask for a second number, I read it in. I then pass both of those numbers over to the add to nums, which again is my assembly code. I get the result, and I then show it back out to the console or to the screen. Now to actually compile and link here, I'm using Watcom's WCL. And this is the syntax I'm currently using for doing this, but you'll notice that I am pointing to the CPP file, my C++ file, which is, in this case, I called it GFX test2. And I also have to point to the object file from that assembly, which is graphics.obj in this case. Now the result of this is a single executable, and that executable contains the functionality from my assembly library plus the C++. Now, instead of the __ cdecl up above, there is an option for WCL where I can just tell it the default is C style. I did try that, but then there's other things that break when I do that in IOStream or this standard int. I run into problems there that it does not compile correctly when I flip that. And it's just a parameter -ECC if I remember correctly, but I took that back out, and I'm just going to do this on a per external functional reference of underscore cdecl. That's easy to do and lets me control this a bit. So then the result of that is I can now take this compiled executable, in this case gfx test2.exe. I can copy it over to my CF card. I can then put that CF card into my 286 system running FreeDOS, boot up to FreeDOS, and run that executable. So here I have my 286 system booted up to FreeDOS, and I've changed into a directory called rehsd. And I do a directory, and you can see I have this program in here called add2nums.exe. That's the one that I actually just built. I just renamed it. Instead of being graphics test2.exe, I renamed it to call it add2nums.exe. But I'll go ahead and run it. And what you're going to see is that it says, let's add two numbers. It asks me for the first number, asks me for the second number, and shows me a result. So very, very simple test, but this just helps me validate that from my C++, I am able to leverage an assembly object file that I've assembled, take advantage of that assembly code, and I run my C++, I gather some input, I make a call to that assembly function to add two numbers, and I get back a result, and I display that. So I think this is going to give me a good foundation now that I can either leverage assembly to get to hardware on my system, for example, on my video card, or I could use C++ to get to that same hardware, or I can go through an interrupt call to get to my BIOS to get to that hardware, or whatever combination of those that seems to make the most sense. And I'll do some testing in the future about performance. You know, will I even notice a difference if I'm doing these graphical primitives in assembly versus C++? You know, my assembly skills maybe can't take advantage of all the things I could do in assembly, but I'm learning. So it'll be interesting to do some testing, like all my pixel writes. If I do those from assembly versus C++, will I notice any performance difference? So more to come there. For those of you that have been doing a lot of this, if you've got any I guess tips or tricks or pointers, let me know. But at this point, this seems like this foundation is working. I have a dev environment set up and running. I can edit the files for assembly and C++. I can assemble the assembly files, and I can link and compile for the C++. And it seems like that compiled executable then I can load into FreeDOS on my 286 hardware, and it is running just fine. So pretty cool stuff. I'm excited to get to this point. I thought I was further away from this, but after being asked by Shriva, I thought, well, let's just go see if there is a big gap before I could get to this, and it seems like that gap actually wasn't so big. So I'm excited that I can now take advantage of low-level assembly, a little bit higher-level C++, any combination thereof, and leverage my operating system, my BIOS, my hardware. So more to come on this as I learn more, but hopefully this is maybe a template or a framework that is helpful for me as I proceed.